Geometry Spring OST 2019, question number 13. It says a company wants to design a cylindrical object that has a height of 10 centimeters and a volume of at least 2,000 cubic centimeters, but not more than 2,500 cubic centimeters. What is a possible radius in centimeters of the cylinder? So this is a topic 11 volume question, right? These are volume, cubic, it says volume. So I know it's a cylinder, so if I go to my formulas here, it'll tell me what the volume of a cylinder is. There you go. Volume equals pi r squared h. So I'm going to write that down. All right? Volume equals pi r squared h. Okay, so I'm going to use this a couple times, right? I have two situations. The first situation is I have a height of 10, and I need a volume of at least 2,000, right? So I'm going to plug that in. So 2,000 equals pi r squared times 10. Okay, I'm going to solve this for r, okay? I'm going to divide by 10 pi to get the 10 and the pi away from the r squared. So this gives me r squared, and I'll divide that by 10, I'll divide 2,000 by 10 pi. So I'll get my calculator out. Shrink it down. There we go. So we're going to do 2,000 divided by 10 pi. And again, the pi button is right here. If you use the calculator, pi. You can also type out pi, and it does it for you. And that's 6366 or 0.66, right? So that's going to be the radius squared. 63.66. And now to get r by itself, you have to take the square root. So I'm going to take the square root of that number, and I don't want to round. So watch what I do, right? I open up the next box, find your square root, and then you can actually highlight that, and you can copy Control C. And then you can click into a Control V. And there we go. This is going to give us the smallest radius we could be. So the smallest radius we could be is 7.978. Right? So if we actually round that, that would be 8.0. So this is the smallest because we want to be at least that big. Right? Okay. But now situation 2. Right? If we look at situation 2, now we want to have a height of 10 still, but we want to have no more than 2,500 cubic centimeters. So now we're going to do the same problem all over again, right? And I'll do it right here, except now your volume is 2,500. So we're going to do 2,500 equals pi r squared times 10. So we're still going to divide by 10 pi. And what I'm going to do is I'm just going to go back to my calculator and look at my work. And I'll change that 2,000 to a 2,500. Okay, so that's 79.57 blah blah blah, that equals r squared, and then take the square root, right? And this time I have to copy Control C, and now I need to kind of highlight that and paste over top of that, Control V, and there we go. And this r value is now 8.9. So I have to be somewhere in between 8.0 and 8.9. Now it says round to the nearest hundredth, right? So we can have any number in between those two to the nearest hundredth, which is goofy, right? So I'm going to pick 8.23, right? LeBron, right? 8.23. So that would be a radius we could be so that we are in between those two numbers. Now, if you had time to check, you could always plug it in, right? So we could do pi, parentheses, 8.23, close parentheses squared, times 10, which is our height. And there you go, 2,100, in between 2,000 and 2,500 cubic centimeters.